Have you ever looked at the moon and wondered what lies beneath its silent surface? Beyond its familiar craters and seas of gray, dust hides a scar, so vast, so deep, it defies imagination. This is the South Pole, Aitken Basin, the largest, deepest impact crater on the moon, and one of the biggest in our entire solar system. A colossal wound nearly 1,200 miles wide and 250 miles deep, filled with mysteries that could rewrite what we know about how the moon, and even Earth, came to be. Most of us only see one side of the moon, the near side. But on the far side, the hidden hemisphere that never faces Earth, lies something extraordinary. The South Pole, Aitken Basin, stretches across the moon's southern far side, a massive scar carved billions of years ago by an asteroid the size of a small continent. This impact was so powerful it nearly cracked the moon's crust in half. Imagine a crater so wide it could stretch from New York to Miami, and so deep it could swallow Mount Everest several times over. That's the scale of the South Pole, Aitken Basin, 1,200 miles long, 1,000 miles across, and 250 miles deep. But it's not perfectly round. Its southern rim tapers like a teardrop, a clue that reveals the asteroid didn't strike straight down, but at a sharp, northern angle. This wasn't a head-on collision. It was a glancing blow from the north. Beneath the basin lies evidence of the moon's violent youth, a time when molten oceans of magma covered its surface. Scientists found that the basin's southern half is thicker with debris, while the northern side is thinner and smoother. This asymmetry tells a story, one of direction, energy, and chaos frozen in time. Jeffrey C. Andrews-Hanna and his team at the University of Arizona's Lunar and Planetary Laboratory combined shape, gravity, and impact physics into one incredible model. And the results match other worlds: Hellas Basin on Mars, Sputnik Planitia on Pluto, all showing the same tapering fingerprint of oblique impacts. Now comes a curious twist, a chemical signature buried deep in the moon's crust. Scientists call it KREEP, short for potassium, rare earth elements, and phosphorus. It's the residue left behind from the moon's ancient magma ocean billions of years ago. KREP is like a time capsule containing radioactive materials such as thorium that release heat as they decay. Interestingly, most of this KREP is concentrated on the near side of the moon. But the South Pole, Aitken Basin? It has a strange pattern. Thorium-rich material appears only in the southwest, not the northeast. The moon's crust isn't uniform. Data from NASA's Grail mission shows the far side has a crust far thicker than the near side. That difference might explain why lunar Maria, the dark seas of lava, exist only on the side we see. The South Pole, Aitken Basin, connects these mysteries. Its thorium-rich ejecta suggests that beneath its southwestern rim, molten rock once lingered, perhaps long after the rest of the moon solidified. In 2024, China's Chang'e 6 mission landed in the northeastern part of the basin. It scooped up samples and returned them to Earth, the first ever collected from the moon's far side. Surprisingly, the samples contained little evidence of KREP. That means the thorium-rich material in the southwest must have come from deeper layers of molten rock, layers untouched by Chang'e 6's landing site. Our study shows these samples may reveal even more about the moon's early evolution than we thought, said Andrews-Hanna. Now, NASA's Artemis program plans to send astronauts to this very region, the South Polar Highlands within the basin's downrange rim. Their goal? To collect rocks from ancient impact debris and volatile-rich terrain. If they succeed, these samples could pinpoint the moon's cooling timeline, when its magma ocean solidified, and how long it stayed warm enough for dramatic internal changes. Each rock is a chapter in lunar history. Each layer tells us how deep the impact dug, and how the moon's hidden heat shaped its destiny. The South Pole, Aitken Basin, tells a single, elegant story, one that links impact, chemistry, and heat. A glancing strike from the north sculpted the basin. It exposed ancient materials that traced the moon's fiery beginning. It even explains why one half of the moon is darker and the other bright and mountainous. Every ridge and shadow still holds that frozen moment when chaos shaped calm and violence carved beauty. But the story doesn't end here. The same methods used on the South Pole, Aitken Basin, are now unlocking mysteries across our solar system. Tapered basins, mineral gradients, and radioactive signatures serve as cosmic breadcrumbs, helping scientists reconstruct the violent birth of planets and moons. Every crater is a fossil, and together, they tell the history of our cosmic neighborhood. The South Pole, Aitken Basin, is more than a crater. It's a window into deep time. It holds the fingerprints of ancient fire, frozen in silence for 4 billion years. And soon, human footprints may join them, as we return to explore the moon's most mysterious frontier. If you enjoyed this journey into the moon's hidden world, don't forget to like, share, and subscribe. And for more fascinating cosmic discoveries, visit Documentary Times, where the universe comes alive through stories that matter.